Yeah, till now we saw the support of the language and we saw the library also. Like Java is giving you extensive support for what? All the programming things, plus it is giving you the built-in classes also. Everything is fine. Still some more topics are pending in Java which we have to cover. Like one which is pending is exception handling. So today we'll get into exception handling. So now exception handling is the subject today. So first of all, what is exception? What is exception? It's a runtime error. Exception is a runtime error which causes the program to terminate. It's a runtime error which causes the program to terminate. Okay. Now what is handling now? It's a mechanism of handling the runtime error, okay, and not letting the program terminate. Handling it, okay, and not letting the program terminate. It's the mechanism of handling the runtime error. Okay, then next, mechanism of handling the error, retain control within program, and continue the program execution normally. Program execution normally. Now this is a very vast subject. Exception handling is a very vast subject. It's a mechanism of handling the runtime error, retain control within the program and continue the program execution normally. This is exception handling. Understood? What do you mean by exception? What do you mean by exception handling? So to understand more this, we'll see some more topics. Okay. See, in whenever you program, okay, there are two types of errors you get. Errors means we get programming errors. These programming errors can be classified into two types. These programming errors can be classified into two types. One is compilation error. Second one would be a runtime error. Now compilation error. Are you aware of compilation error? So, you know what are compilation errors. Okay, you know what are compilation errors now. So these are nothing but syntax problems. These are nothing but syntax errors, and solution for this would be write proper code. You know how to fix this problem now. The solution for compilation error would be what? Why compilation errors is because of syntax, and the solution for that is write proper code. Now till now you have not come across runtime errors. Till now you have not come across runtime errors because you have not written any good logic. Okay, so it will take a lot of time for you to understand what are runtime errors. Nearly what is compilation error? How many days you took to understand? 2 months now. Nearly you took to understand exactly what is a compilation error. You have taken around 2 months now. Okay. Similarly, what is a runtime error to understand? It will take some time. In one program, 1-2 programs, you will not understand. So gradually you will experience this, and then you will come to understand this. Okay. So runtime errors again can be classified into two things. And if a runtime error occurs, program will never execute. It will terminate. If a runtime error happens, program will terminate. Okay. Again, it can be classified into two types. One is exception, other one is error. Runtime errors are only classified into two types. What is that? Exception and error. Now what is an exception? So exception is a runtime error which can be handled. Understood? Now what is the error? Error is a runtime error which cannot be handled. That's the major difference between both of them. So exception, as I wrote just now, it's a runtime error which can be handled. and here program will not terminate. Here, okay, it's a runtime error which cannot be handled. That's the most important thing now. It's a runtime error which cannot, here which can. That's the difference, which cannot be handled. Okay, so here program will terminate. You have seen some of them already. You have seen error also, you have seen exception also. Till now your program, no? Okay, you have seen, but you have not observed that, or we didn't pay more attention to that. But today we'll pay full attention to that and study this full thing. Okay, solution means how do you do exception handling. So Java is giving you, okay, solution to this is 5 keywords. Try, catch, finally, throw, and the last one would be throws. Just throw and throws. Solution for this would be, one second. First one, try. Second one, catch. Third one, finally. Fourth one, throw. Fifth one, throws. So these are all again keywords now. Java is giving you 5 keywords for exception handling. Understood? So here solution. Okay. Write proper code. Means you have to change and write proper code. That's it. If an error occurs, change and write proper code. So first you have to understand this 3 category. What is that? First you have to understand what is compilation error and runtime error. After understanding that, then you have to understand what is exception and error. After you understand, then you will understand how to solve your problems. So compilation error, almost all you are perfect now. Almost all there are no problems with compilation error. Understood? But we are facing problems in runtime errors, till now which you are not observed. Okay, so now we'll start observing. And again runtime errors can be classified into what? Exception and error. Okay, so in exception, what is the exception now? See, both are runtime errors only. Both are exception and error are what? Both runtime errors only. But the difference is this can be handled, this cannot be handled. So it's a big subject. And all this you'll start understanding with more examples only. Are you clear with this now? Okay, still some more things. So these are the 5 keywords. These are the 5 keywords provided by Java for doing what? Provided by Java for doing exception handling. So in other languages, how many keywords you find? You only see. So Java's exception handling mechanism is very, very rich and very, very powerful. Very rich and very powerful. Unimaginable it is. Understood? So you have to study all the keywords. Once you understand all the keywords, then you can know exactly how to write good logic now. Okay, fine then. Shall I clear all this? Clear? These are 5 keywords provided by Java for doing exception handling. Fine. See, some exceptions you already seen, like class cast exception, number format exception you have seen. You already seen, but let us go more deeper into that. Error also you have seen. Like example, no class definition found error, no such method error. So why they occur and all that, now we'll start going more deeper into that. Clear? All you have seen, only we have to understand it properly now. So then next, there is one superclass of all classes. You know that, no? Object. There is one superclass of all classes. It is called as class object. Under that, there are 2 major subclasses. Sorry, first 1 second. Every class in Java is a subclass of object. Remember that. One subclass of this would be throwable. Okay, there are many. String is there, string, all that will continue. But today we are talking about things related to exception handling. That's why we are talking only classes related to exception. Clear? So under throwable, there are two main classes now. One becomes exception, the other becomes error. So these are the two main subclasses of throwable. So again under exception, see, these are all built-in classes. You don't have to worry too much about all this now. These are all built-in classes. So this is how you are studying the library. One side you are studying what? So these are the built-in classes. Now what we are seeing is Java support. Okay, built-in classes for exception handling. Java is giving you plenty of built-in classes. Built-in classes means what? Built-in classes for exception handling in Java means provided by Java. So they are giving you so many classes, agreed. They are giving you so many classes, but this is how they are organizing it. How they are organizing? See this. Some classes are direct subclasses of which one? Exception. IO exception, SQL exception. You don't have to worry too much about this. These are all class names, and one by one you start studying them. Why they occur and all that. Okay. SQL exception. So it is in one line. Since I am not, it's a class. You know how you write IO exception, no? This is how you write. But since I am not having space, so I am writing it like this. SQL exception should be written like this. It's a class name. Since we are not having space, I am writing it in next line. Okay. IO exception, SQL exception. Then one more is there. File not found exception. See, this is also in single line. But since they are very big names, I am writing it in what? 3-4 lines like this. File not found exception. If you write it in single line, it will become like this. File not found exception. One second. I am making a mistake. One second. See, IO exception is a one second. File. One second. Just wait a second. Let me complete this table. Then you write. IO exception, SQL exception, class not found exception. Then you are having something called as class not found exception, interrupted exception, see this. Some classes are direct subclasses of what? Exception. IO, SQL, class not found, interrupt, they are all subclasses of exception. Again, file not found exception is a subclass of what? IO exception. This is the story. Okay, but here there is one more big classification. And one more class is there called as runtime exception. Some classes are direct subclasses of exception, some classes are subclasses like this. Example is for runtime exception, arithmetic exception, these are all class names. You don't have to worry. One by one you start seeing. Arithmetic exception, you have seen the famous null pointer exception. Then array, index, out, of, bounds, exception. I've seen many like this. Okay, then under error, I got something called as class no class definition found error. No class definition found error. no class definition found error, no such method error, no such method error, virtual machine error, under virtual machine error there are two errors: out of memory error it's the hierarchy, problem related with heap. This is problem related with stack. See, number of classes are there now. It will go on now. The story will continue. Okay. So too many things are there to study. Let's start this now. So the thing is, see, I'll just tell you how the classes have been organized here. There's one class called as object. Under it there is a subclass called as throwable. Throwable is having two subclasses called as what? Exception and error. Now, under exception, see, there are some classes. Just notice this. This is very important now. IO exception, SQL exception, class not found exception. These are all direct subclasses of what? Exception. Understood? Fine. Under exception, there is one more exception called as runtime exception. So some are subclasses of runtime exception. This is one major category or classification you have to understand. So some exceptions are direct subclasses of what? Exception. Some exceptions are subclasses of what? Runtime exception. Okay, some exceptions are subclasses of runtime exception. But again, runtime exception is a subclass of what? Exception. But this is how they are classifying. Why they are classified like this, you'll understand very clearly. But just notice this. Fine. This is exception. Next, other side you have got error. See this. No class definition found error, no such method error, virtual machine error. We have discussed this also. These are all classes again. Okay. And under virtual machine error, one subclass is what? Out of memory error, stack overflow error. And what is out of memory error? We have discussed this. This is problem related with heap. What is stack overflow error? That is problem related with stack. We have discussed few of these topics. Understood? So again we will discuss it in depth. Don't worry. Okay. Now see again. All the classes. See this one. All the subclasses of exception. All the subclasses of exception. They are called as checked exceptions. Understand that. These are technically called as checked exception. They are called as checked exceptions, or they are also known as compile time exceptions. They'll ask you in interview, give some example for checked exceptions or compile time exceptions. So that time you have to tell any exception which is a subclass of what? Exception. That's it. Similarly, they'll ask you give some examples for what? Unchecked exceptions or runtime exceptions. So these are unchecked exceptions. What you are seeing here are called as what? Unchecked exceptions or runtime exceptions. Understood? So all these what you are seeing are called as what? Checked. All of these are called as what? Unchecked. So very clearly you'll understand this. You don't have to worry. Okay. So just we'll start off now. Fine now. Means in Java what they have designed is, say in other languages when you code now, program terminates. For what reason it is terminating, it will never know. You will never come to know. But in Java it's not like that. Whenever your program terminates, it will terminate. But you will be having a clear message there. Why your program got terminated. You have seen many times. It has happened. Your program has got terminated. But you have got a message there. Till now you have not understood the message. But today we are learning that message only. Why the program is getting terminated. What is that message. And how it will be helpful for us to debug and all that. We'll start studying now. But it's very clearly organized. Okay, remember in Java when your program terminates now, it is very very clear. Okay, you will have one print there, one message will be there. Anything which is of type exception, you have to understand it can be handled. Anything which is of type error cannot be handled. For that you have to change your complete code itself. So this is how they have designed it. Okay, in many languages you will not even have the idea about why your program has got terminated. But Java very clearly tells why your program has got terminated and whether it can be handled or not. That also it will tell. It will terminate. and at the same time it will give a message. It's like this is exception, please handle it, or this is error, please handle it. So when you see an example, you'll understand all these concepts now. So very fast I'll be getting into an example now. Shall I clear all this? Understood now? And notice here one thing, this is very important. File not found exception is a subclass of what? IO exception. IO exception is a subclass of exception. Like this, other things will be there. Okay, fine. I'll tell you why I highlighted that very shortly. Clear? Yes, so see this exception handling. All these points with examples only you understand, but just start understanding little now. In Java, they are programming. There are two types of error which I discussed now. One is the compilation error, other one is the runtime error. What is compilation error? Is an error which occurs at compilation time. They are syntax error and they have to be solved with proper coding. What is runtime error? Which occurs? This is an error which occurs at runtime and can cause the program to terminate. It can cause. Okay, but again it can be classified into two types. Okay, so exception is a runtime error which can cause the program to terminate. It can cause the program to terminate, but you can handle the exception and continue the program execution. Okay, here program does not terminate and execution continues normally. Okay, means whenever you see something like number format exception, IO exception, something like this, that time what you can do? You can decide to handle it. Okay, next. But if you see something like, see this is a runtime error which will cause the program to terminate. You cannot handle it and error will terminate the program. So if you see things like this, don't bother of handling it. Which one? The suffix you see very clearly it is classified error. So don't bother to handle it now, because you cannot handle it. You have to change the complete code itself. Okay, now see, Java clearly classifies the reason for program termination and reports the message, so that the developer can decide how to handle the runtime error. Understood? Now all exceptions are subclasses of what? This exception, this is a package. Java.lang.exception is a package. Java.lang is the package, exception is a class name. All errors are subclasses of what? Class error. But both exception and error are subclasses of what? Throwable. This was the hierarchy which I drew just now. Getting it now? This is the hierarchy which I drew just now. Just go through this hierarchy. Clear this hierarchy now? Object is a superclass, throwable, exception, error, same which I drew just now. Fine. Now let's come to this. What is exception? Okay, it's a runtime error which causes the program to terminate, but it can be handled. This is a very important thing what you have to tell in the interview. These are your interview questions. What is an exception? It's a runtime error which will cause the program to terminate, but it can be handled. Next, what is exception handling? It's a mechanism of handling the runtime error and maintaining the normal execution of a program. Normally it will continue executing. Then now, how do you do exception handling? Java has given you what? 5 keywords. Try, catch, finally, throws. You can, okay. Throw and throws. You can write it in any order, no problem. These are the 5 keywords. Fine. Now what is the advantage of exception handling? What is the advantage? Program will not terminate and it will retain the control within the program. That's the main advantage. And also you can fix the error. These are the two main advantages of doing exception handling. Okay, what is error? It's a runtime error which cannot be handled and causes what? The program to terminate. Here definitely program will terminate. Fine. How do you handle error? Okay, Java does not support error handling mechanism. It has to be solved with proper coding. Not only in Java, even in any language, there is no mechanism called as error handling. You will not find any subject called as error handling. Same is with Java also. Okay, fine. Next, let us see this. In most of the other languages, if you do not handle exception, what happens? Program or application will terminate. Your C program, some exception will occur or some problem occurs, runtime error. When you coded C, some runtime error occurred. What happens? Your program was getting terminated, no doubt about it. But at the same time, what was happening? System also was getting terminated. But you have coded so many programs till now. Okay, in Java, program was terminating, but system was not terminating. Yes or no? So I have built it is a very robust one. Which one? JVM. Let's see now. So means in other languages this is the problem. But in Java, let's see what happens. In Java, whenever an exception occurs, if the developer does not handle it, following things will happen. Program will terminate. Okay, but your system will not crash. It will be handled by the JVM. It will be handled by the JVM. We will get into an example and observe all this now. Okay, but in Java it is guaranteed that your system doesn't crash. So in Java you have to bother only about one thing. What? Handling your program. But in other languages you have to bother about what? Two things. You should take care of application also not getting terminated, and at the same time you have to take care of system not getting terminated. But in Java you are already relieved of one thing. What? Do not bother of your system crashing. You have to only bother about application crashing. Okay, so how they have done all this, we'll see with an example only. Yeah? Okay, in Java whenever an exception occurs, see, if the developer does not handle it, program will terminate. That we'll see how to handle it now. Okay, but exception will be caught by the default, handled by the default handler of the JVM. Because of this, what happens here in Java, even though the application is getting terminated, system does not crash. Clearly I underlined this, see this point, because this exception is getting handled by the default handler of the JVM. Why does system not crash in Java? Because it's handled by the default handler of the JVM. Okay, so let's see an example and then try to understand the next point now. Yeah. So we'll take the same famous example now, which one? Dividing by 0 itself. Okay, then we'll get into more complex programs. Understood? First we'll start off with the simple program, because when we start exception handling, we start off with the simple program only. So let's see the program now. What the public static void main? Fine. Now see this. Int x is equal to 10. Int y is equal to 0. Int z is equal to 0. SOP value of x before division same way I can print what? Plus y plus z. You print all the SOPs. Value you can print of what? Is value of y before division. Z. Okay, fine. Now see this. Z is equal to x divided by y. What am I doing? I'm doing division. Fine. So then I'll print value of z is plus z. Okay. I can continue. I can write end of main. Like this. See, this is the program now. And you know, when you start your program execution starts, we'll first compile. First we'll start from compilation. I'll compile it. It compiles. Because are there any syntax errors here? 100% no syntax errors, definitely it will compile. If any compilation errors are there, you have to solve it with what? Proper coding. Compilation errors you know now, but I'm moving into what? Runtime errors. Okay, so let's compile. Program will compile. Okay, first let me take the value of 2. First let me take the value of 2. Then I'll come back to 0. Program will compile. Now also it will compile, because program is checking what? Syntax. Like it will be checking. What it will be checking? What it is checking? Are you giving an int value to int? Means 10 is what? A numerical value. Are you giving it to type int? Yes. Same way it will check. Then it will check z is equal to x by y. It will again check what? Are you dividing int by int? That is why it will be checking. Okay, and the result you're storing it in what? Int. Because the result of the outcome of a arithmetic expression is numerical value. I'm storing it in numeric. All that it will check. It will compile. And it will, when you execute now, the program will execute successfully also. There's no problem with this. Understood? There's no problem with this. Okay. But by chance, if the value of y is changed to 0 now. By chance, if the value of y is changed to 0 now again it will compile. There's no problem, because compiler is not checking what? The values. Compiler is checking what? Only the syntax. Again it checks. Are you giving the value of numeric to numeric? 0 to y, all that is correct. Are you dividing int by int? Everything is correct, it will compile. So it will go past the compiler now. But during runtime, you'll start getting the errors. You'll start getting errors during runtime. See what happens. Here program starts execution, this line executes now. See, now value is evaluated. During compilation time, value is not evaluated. Compiler is checking only when you are only checking what are you dividing int by int. Okay, but as you go on executing, now values will come into existence. 10 will come into existence, it will be stored in x. 0 will come into existence, it will be stored in y. 0 will come into existence, it will be stored in z, like this. It will print, and here it is trying to do division. So now it will check what? It will try to divide 10 by 0. This is runtime now. Compiler will not be having values. Okay, compiler only checks the syntax, but during runtimes values are come into existence. So 10 by 0, it cannot divide. Okay, now these things cannot be detected by what? Compiler. It cannot be detected by compiler. These are logical problems which will enter the runtime. Okay, and Java gives extensive support for what? This also now. Like what happens, let's see. So as soon as the exception occurs here, means as soon as the runtime error occurs, one error is occurring now. Okay, immediately what will Java do? It will take one built-in class. Okay, which will represent this problem. You know which was the class? Arithmetic exception class was there now. Okay, that class will be taken and implicitly an object of that class will be created. I am not creating, you are not creating. Who is going to create an object of arithmetic exception? JVM itself. So for every problems like this, for every runtime errors like this, okay, this is one error what you are saying. For every error, there is one class. Understood? For every error in Java, there is one class. So here which object is getting created? You saw so many classes now. They are all representing one problem. So that's why more problems you will see or more errors you will see, or you will understand all those classes now. Like you saw number format exception, class cast exception. So why that exception occurring means you have to see with the example only. So right now we are discussing arithmetic exception now. So here arithmetic exception object will be created. So once this object is created, an object gets created. So this object, you know, in Java every object encapsulates some information. So what does this object contain now? It contains information about this error. It will be containing information about this error. Okay, so it contains what? Info about the runtime error. Why it occurred, where it occurred, all that it will be containing. Okay, so now it checks. After that object is created, it checks, are you handling this error? We have not written any code till now to handle this error. If you don't handle the error, now what happens? Question is that. If you don't handle this error, now what happens? If you are not handling it, immediately these lines are skipped. Program terminates. I mean to say program is terminated now. These two lines will not be executed. Program has got terminated, and it will come, if you are not handling it, that object will come outside the method. So when an exception occurs, what happens? An object means whenever a runtime error occurs, an object gets created. And once this object gets created, it will check, are you handling that object inside your method? If you are not handling that object inside the method, okay, it will come outside the method. So if it comes outside the method, where it will go? To the caller, JVM itself it will go. Who called this method? JVM. It will go to the caller of the method. So now JVM will get it. Now what will JVM do? It will catch it. It means it will handle it and it will print the message. What message it prints? Okay, this program got terminated because of arithmetic exception, line number and all that message it will give. So your program has got terminated, but you are getting the message now. Okay, so now see, program got terminated, yes or no? I'll show you this output. The program gets terminated, but system did not crash now. The same program if you try in any other language, what will happen? Program will also terminate, plus what? System also will terminate. So in Java we don't bother about writing logic for what? System getting terminated, because by default JVM will be solving the problem now. We only have to take care of, to see to that your application doesn't terminate. Now how will you do that? So that is when we start writing using the keywords now, provided for what? Exception handling. Okay, so how we do now? The same code. See this, I'll write it here. Class demo, just 1 second. This contains info about what? Runtime error. Is okay. See now, to rectify this problem now, what I'll do? Int x is equal to 10. Int y is equal to 0. Okay. So if you find that there's a problem, put this code in what? Something called as try catch. So we'll start using try catch now. Okay. Int z is equal to 0, z is equal to x by y. Catch. So I came to know now why my program is getting terminated now. Okay, I came to know why the program is getting terminated. So I'll catch it now. With what? Arithmetic exception. SOPE. You can print this. So now what happens? See, we are learning how to use try catch now. Why to use try catch? How you means parallelly we are learning two things: how to handle the exception, and we are introducing what? Keywords also now. So just observe this. So if at all an exception occurs here, okay, immediately it will not terminate. It will be caught by the catch block, and program execution will continue. After what? Catch block. Program will not terminate now. Understood? Program will not terminate. So we'll come to try catch next. Okay. But see here, by chance if I have written any statements, SOP value of Z is plus Z. See what has happened? Here the exception object gets created now. Program goes on executing. So here what happens? Arithmetic exception object is created. Once it is created, now see, all the lines in the try block will be skipped now. This is called as a block. Try block. All the lines in the try block will be skipped as soon as the exception occurs. Here it is occurring now. So this line will be skipped. Control immediately shifts from where? That line to catch. It is caught now, because earlier it was not caught because you have not written it. But now I have written it. So it will be caught. Once it is caught, now it will continue the execution. So you do not let the program terminate this time. Okay, that is the reason. See, we are doing exception handling for two reasons. One, not to let the program terminate. Remember that. Second one is to fix the problem also. Still I am not fixing the problem. I will fix the problem very shortly. But observe that I am not letting the program terminate. Java, it is very simple. Just hardly what did you do now? Just used try catch. If you use try catch, finished. Your program is not getting terminated. So now why do you use the try block? Why do you use the try block? Try block is used to write the code which is going to cause exception. Any problem, if you doubt, some problem will occur. So that code you will put it into the try block. And if it occurs, what will you do? You will catch it in the catch block. And this catch block is called as exception handler. So if you don't write the exception handler, what will happen? It will go outside the method. If you are not writing it in your method, if you are not writing the exception handler in your method, it will go outside the method and it will be handled by what? The default handler. Default handler is nothing but the JVM. Understood? So here it will be handled by your handler, and once it will handle, it will continue the execution. So remember, but this is very important. After the exception, the statements inside the try block will be skipped. That is very important. Fine. Then next. By chance, if an exception doesn't occur. By chance, if an exception doesn't occur. So no, except try block will execute fully, successfully, catch will not be executed. Catch will not be executed. So it works like this. If error occurs, then catch block will execute. If error doesn't execute, then if exception occurs or if error occurs, then catch block will execute. If it doesn't occur, catch block will not execute. It's something like if and else. If some problem else means if some problem here, then catch block will execute. If problem doesn't occur here, then catch block will not execute. If problem doesn't occur. Clear? So we'll see with programs only now, and it's better I type and show you now. Okay, so once I type and show, you'll start understanding all these problems now. So we are going with the first two keywords now. Which one? Try and catch. Then we'll go with other keywords. Which one? Throw, throws and all that. Clear? You can create a new workspace today, okay, because all your projects will be put into a new workspace. So whenever you start off a topic, put your projects into new workspace. So you can go D drive, Eclipse examples, August 2013, Ravi Kumar, Java examples, core Java is here. So this is the place where we are creating all our workspace. So you can create one more workspace now called as what? Exception handling. Understood? So in this, what will I do? Copy that path. Now open Eclipse. There again metadata will be created. So a new workspace now. Don't put it in lang package. Okay. So first time, yeah. New project, I'll give the name as 01 exception. Yeah. So I'll create a folder, package com dot cluster new class, yeah, exception demo 1. You need main now? Yes. So write it. So this is the first program. Let's see now. We'll increase the font size. Yeah, let's start coding. Value of x before division is any print statements you want to give, that's your wish. So these are your normally written logic till now, okay, and you are writing excellent logic because problems were not occurring, yes or no? But from now they will happen. See here till now we have hard coded the values. Okay, once again. Some more prints will put. Put more print statements, else you will not understand the flow now. It will alter the flow. Exceptions will alter the flow. Understood? So let's see this now. Let's run the program now. It runs successfully because there are no errors which occur. Is the compiler giving any error to you now? Is the compiler reporting any error? No, no red mark, no. Because syntax is correct. It will check. Are you giving all this int value to int and all that? Here it checks, are you dividing int by int? It is not checking whether you are dividing 10 by 2. Because values are evaluated at runtime. Values are not evaluated during compilation time. Only during runtime values will come into existence, and that's when it will actually divide. So compiler checked, are you dividing int by int, it checks. But during runtime, actually values are divided. That's the difference between compiler and runtime. Understood? Fine. Now see this, begin main, value of x before division is 10. Value of y before division is, I think I'll put after this. All the statements are got executed. See this, before main, first is what, before division, begin main, before division, before all these three output. You can see it is here. All these three output what you are seeing is there. Okay. Next, after division you can see these three output. Sorry, this one also I'll change it to end main. And now see after division what it is? Change it. This will also print what? End main. So program executed successfully. There is no problem. Okay. Because you have given proper values. Fine. But don't think, see now, I'll change it to 0. Yes, you will definitely get a question. I know very well it is 0. Why should I divide by 0? This is an immediate question. Okay, the answer is, we will not hard code any value. These values will be coming dynamically from user. You'll be having on screen, please enter 2 numbers. Okay, so user will give the value there. He can give any value. You can't expect what value is giving. He can give 100 also, he can give 0 also. So like this, they'll enter dynamically. So that user screens, which one? See, supposingly this is a screen. Enter number 1. Enter number 2. So user will give the value later on when you develop the applications. Okay, submit to divide. So he will give whatever value you want. He'll give 10 and 0 or 0 and 10, whatever he wants he'll give. We can't force him. I'll tell him please don't enter 0. But if I tell him still clearly a message here, please don't enter 0, what will he do? Deliberately he'll give 0. Understood? Things are like that. So what will happen now? Definitely 0 will enter. Because when he is going to enter we don't know. So once it comes, now obviously any value you get, where will you store? As soon as you get a value into a program, where will you store? Variables only, no? Where will you store? Like this, int x is equal to that value, int y is equal to that value. So now you have to process. After processing you have to give back the answer here. What answer you will give? The result of division is, yes or no? You have to give back the answer. But he can enter any value to you. He can enter, he can give any value, and that's when what happens? Problems will start occurring. So don't think I'm hard coding here, 0. These values will come what? Dynamically, and you have to give back the answer here. Result of the division is so and so. So like this we have to write logics. So we are still continuing to see how to write logics only. Understood? So once we complete exception handling, then you can write good logics. Okay, see this. So now it is 0. Now see the problem. Run as Java application, fine. Now see what happened. X before division is 10. This output you are seeing, these 3 output. These 3 output as, see, it goes on executing line by line, it is executing. After executing line by line, here the problem occurred. What problem occurred? You are seeing here very clearly, but in other languages you will never get the message why it got terminated. The beauty of Java is it's telling you very clearly what? Arithmetic exception has occurred. Not only that, see more information. See it very clearly. Divided by 0 occurred. It has occurred in, see this, in this package, in this class, in this method, in this Java file. This is exception demo is what? Class name. This is what? Method name. Exception demo 1 is what? File name. In one file you can have many classes, no? In one Java file you can have many classes. So it will tell the name of the file. In that file which class, in that class which method, the line number, all that story it is telling you. So once you come to know, what you can do now? You seen it now. What is it of type now? Exception. If it is of type exception, now I will do exception handling. But the same, if you see error, you cannot do anything. So errors we will see later. Now we will concentrate only on what? Exception. We will see many exceptions and you will understand this. So whenever an exception occurs, we can handle it. Clear? So but since we are not handling it, what has happened? The object has got created here. The object has got created. Since you are not handling it, it goes outside the method. It will go outside. Okay, it will go to the caller method. Who is the caller of this main method? JVM. But it is handled by the JVM. Okay, and it is printing the message. See here? It is printing the message. So here what in Java the advantage is application is getting terminated, agreed, but system is not getting terminated. That's a great benefit we have in Java. Clear? So the explanation for this program would be this here. When you run a Java program, JVM invokes. What happens when you do not handle exception is the question. Like pure full explanation for that program now. Okay. So what happens when you do not handle exception? See, when you run a Java program, JVM invokes what? Main method, and then program execution will be started. All the statements inside the main will be executed one by one. Yes or no? Clear till here now? When you run the Java program, main method starts execution, and all the statements inside the main will be executed what? One by one. After that, if any problem happens, then JVM will stop what? The program execution, and following things will happen. The problem is identified. Who is identifying the problem? JVM. Identifies the corresponding Java class. There are so many classes I wrote now. It will pick one class which is suitable to this problem now, or which can represent this problem. Then an exception object means an object of that class will be created, and it contains what? Information about the error. That's the message you are seeing there. Why it got terminated? No. Default handler is printing. So an exception object which contains information about the error is created and thrown inside what? The method. JVM checks is there any catch block or exception handler. Exception handler is nothing but what? Catch block only. It checks is there any try catch. Okay, inside the method. If there is no catch and the exception is not handled, then the object is thrown outside the method. It will go outside the method and main method terminates. The object is caught by the default handler of the JVM and prints message describing the reason for program termination. That is why system does not crash. So this is the entire mechanism here. Okay, so we'll see how to control this now. Means how to we'll see how we cannot we'll not let the program terminate now, and we'll fix the error also. That we'll see next. But before that, one more exception we'll see. This is arithmetic. Now see, I'll write exception, new class. Okay, file name is existing 2. Are you getting this point now? 1 second, yeah. So what is the size of the array? 5. What I'll do, in the 9th index, I'll store a value, something like see this, begin main, end main. Okay, now again see the program here. Here what happens? Is this correct? Compiler can detect this, compiler cannot detect anything here. It checks the syntax, everything is correct. Okay, so now when the program starts off execution, what will happen? Here the problem is happening. So for this problem, the class which it will create, which it will take is array index out of bounds exception. That object will be created. Program will terminate. Definitely program will be terminated and it will not print what? End main. Again it will be controlled by what? Default handler of the JVM only. See this. Okay, see when you are printing output here now, don't get confused. Sometimes it will print before, sometimes it will print after. It will jumble up the output. Especially when you are working with exception handling, it will jumble up. First which one has to print? Begin main. Okay, then it has to print that exception. It will jumble up sometimes. See this. Begin main, end main. Correct now? First exception is printing, so don't get confused. It will only jumble up. If it is jumbling up like that, execute one more time. Okay, or one more time you execute. Finally, you can see the correct output. Okay, in Eclipse, it will be jumbling up like this. Understood? Output. Only in output. Understood? So now begin main is first, but any time did you see end main output? It is not executing. As soon as the problem occurs, what? Program is getting terminated because we are not handling it. Are you understanding now? First understand what are exceptions. So again you can say it is of type what? Exception. Means anything you see as exception can be handled. So Java is very clearly telling you one more advantage. The best benefit of Java, you see, if your program is terminating, it tells very clearly, this is exception you can handle, this is error you cannot handle. So in other languages you can't even identify whether that can be handled or not. But in Java at least there is a clear classification. This can be handled, this cannot be handled. That is why those two subclasses have been created. Which one? Superclass exception, superclass error. Whenever you see an object of type error, I'll come back to error. That also I'll discuss. Okay, that time don't bother to handle it, change your code. But if an exception occurs like this, then you can handle it. By using what? Now it will come now. Try, catch, finally throw and all will come. So first understand what is an exception. Are you clear with this? I'll repeat the previous program also. See here. What is happening? If an exception occurs, what happens? Exception. All the statements are not executed. Check out. See, before division is executed, but after division is not got executed. In this program now, which an exception demo 2, begin main prints, but end main will not execute. See this. Correct, huh? Sometimes when the output is jumbled up, you re-execute, you will get the output correctly. Fine. But if I give a proper value here, might be it will execute. Fine. If you give proper value, it will execute. Begin main and what? and main both will execute. But if you are not giving a proper value, and these values also will come dynamically. At array index and all means the user will be giving the size and then he'll be filling the value. But by chance if you work with an index which is not in the range, you'll start getting what? Array index out of bounds exception. So we saw two. Now let's see how you handle this now. Understood now? So program is getting terminated. I'll not let my program terminate now. So fine. You understood now what's an exception now? Okay. So now I'll write, see this, a new class I'll take the code from here only. Whatever I want, I'll modify. See this, okay, I'll try all this. All this is fine. Now see, exception is occurring here now. So wherever there is a possible chance of exception, what you do? Put it in try block. And value of all this not required now. Value of division is so I know now what is the problem which is occurring. So since I know what is the problem which is occurring, what will I do? I'll write my class now. Which one? Arithmetic exception. And arithmetic exception is a class which is there in lang package. Arithmetic exception is a class which is there in lang package. So right, these are blocks now. Carefully observe, they are blocks. So try is on block, catch is on block. If you want, okay, I'll just eliminate all this output so that it will be neat and clear. Now see this. Okay, so what has happened? Here very interesting thing will happen now. Begin main. Program goes on executing. Okay, so as it goes on executing, it will reach this line. The try block will execute. The try block will start executing. It will divide. If the value is correct, first let us take a correct value. First let's take a correct value. It will divide it, and also it will print what? These two lines. Now in this condition, catch block will not be executed. In this condition, catch block will not be executed, and it will complete the program normally. See this. See, begin main, yes. Then it will come to this line. Begin try, yes. Division is happening, fine. Okay. Once division is happened, it's printing value of z is, and it's also printing end try. Check this out. These two lines it's executing after division. Okay, but catch block did not execute. In fact, I put on SOP there. If you want, you can see sys out inside or begin catch. I'll write begin catch. It is not getting executed. Even you can write end catch. Okay, and end main. Okay. So now you can see catch block is not getting executed at any cost. End try, but end main gets executed. So program got executed normally here. There's no problem. But the same, if I give the value as 0, now things are different. What will happen now? These two lines are not executed. So program means here it is terminated. Actually it's terminating. So here which object is created now? Arithmetic exception. Because division problem is happening, that particular object only is created. For every problem there is one class here. That object is created. So once it is created, now with the JVM checks, are you writing an exception handler here? Yes, we are writing an exception handler. Which is the exception handler? This catch block. So it will check. Okay, then it will be caught here. Once it is caught, it will execute these statements. Okay, so catch block is used for what, you know? Catching the problem and fixing the error. Still I have not fixed the error. Still I have not fixed the error. Okay, I'll fix it. So now see, I'll fix it. So now this is how it will execute this, and then it will continue to execute your main program till the last it goes on executing. Are you clear this? Okay. Now it is caught. It is caught where? Now see here it's, and I'm printing. See this carefully. See the output now. Begin main. Okay. From the beginning we'll go. Begin main, fine, this is begin main. Then begin try. Now begin try. Then begin catch. Because see, these two are not executed. Are these two lines printed? No. So after begin try, you can see these two end try and all has not got executed. Straight away it will go to what? Begin catch. And now you check this carefully. SOPE I have printed there. Can you notice that? SOPE E is what? E is a variable of type arithmetic exception. E is a variable of type arithmetic exception. So it's printing what? It's not printing the address. It's printing what? The message. It's printing the message. Means again, toString has been overridden in this class also. So in many classes they'll be overriding it. And this class is containing information about the error. The same message was getting displayed where? By the default handler, but with extra things. Which one? Line number and all that it was printing. Here also if you want you can get it. The default handler was displaying what? Class name, file name, method name, everything it was displaying. No. Same way you can get the information here. But SOPE prints you only the which one? SOPE prints only message like this. Why your program got terminated? See, every exception, every object in Java encapsulates one information. Remember that. And after that end catch will execute, and after that end main will execute. After that end main will execute. Are you clear with this? Okay, fine. See, here just understand what is happening. This flow. See, as soon as the exception occurs here, okay, here the exception is occurring now. So once the exception occurs here, okay, an object representing that problem gets created. That is nothing but arithmetic exception. So these statements are skipped. These statements are skipped. Immediately control this means it will check, have you written an exception handler? If you have written it, it comes here. If you have not written, which was happening in the previous case, it was going outside the method. But since I have written the exception handler inside the method, understanding now, since I have written the exception handler inside the method, it will be caught here, catch statement gets executed. After catch statement is completes execution, this line gets executed. Means your program is not getting terminated. Observe that. Some statements are skipped. I agree. We'll see how you can execute that later. Understood? But what happens? Your program is not getting terminated. So first thing what we learned is by using exception handling, we can retain the control within the program and not let the program terminate. That is what we are doing now. Second, we have to study what? How to fix the error. Two things we have to study here. How to retain the control and continue the execution normally. And then we have to see how to fix the error. I have completed one. Which one? How to retain the control. And one more thing. If you want to understand what is this catch arithmetic exception syntax, E is a variable of type what? Arithmetic exception. So here the object is created now. Which object? Here an arithmetic exception object is created. The reference of that object is given to this E. Nothing else will happen. So E is a variable which will refer to that object. And SOPE, when you print, what happens? It will print the message. toString gets executed. So E is a variable which will be referring to that particular object now. Are you clear with this? What is E? So remember, we never create this object. This object is getting created implicitly. Okay, whenever a problem or error occurs during runtime, JVM itself will create that object implicitly, and if you return the exception, it will be caught here. And this variable E, whatever you are writing here, any variable name you can give, A, E, anything you give. I have just given the name E here. It's a variable name. Like you write now, hello H. What is H? H is a variable of type hello. Same way, arithmetic exception is a class. E is a variable name, so it will refer to that object. Understanding the syntax now? Try catch arithmetic exception E. SOPE will print what? The toString overridden method. Since it has, otherwise it would have printed the address. Okay, some more methods we'll see. See now, not only that, see this will continue. If you, and this is very useful in debugging now. After catching the exception now, you can print why it got terminated now. See, these are very important now. SOPE you can print. Now see this. I'll comment. Okay. So then after that you can print something called as E dot print. This is a very important method. You can call it in any exception. And remember, these two methods are present in class throwable. Where are these two methods present? First I'll show you. Print stack trace. See this. I'm commenting SOPE. Just see this now. And these are two important methods which you use extensively for debugging. See this. I'll run the program. So it's telling what? Same output. Divided by 0, the class name, the method name, which you are seeing, which was printed by what? Default handler of the JVM. So default handler of the JVM, if you don't handle, what it will do? It will catch it and it will call this method. Same message you are seeing. So if you want to get that same information in your program, just call e dot print stack trace. Okay. So SOP E will print what? SOP E will print only this much. SOP E will print only this much. And if you print e dot print stack trace, it will print you full this much. What? From here to here it's printing now. So see this output. SOP E. I didn't have I commented SOP E. Now I'll comment this one e dot print stack trace and see this. See, these are very important things to debug. We use now SOP E, check what it prints. Only this much. Understood? Are you clear? So e dot print stack trace will print you everything. Now one more is there which we use extensively. Sys out of e dot get message. So these are the two methods, print stack trace and get message, which we use extensively for debugging. SOP, you have to put it in SOP. E dot get message return type is string, put it in SOP. But e dot print stack trace, directly you call it, it will print. So it's giving you this message. What is that? Only by 0. Only some simple message it gives you. But anyway, we use this for debugging lot. Get message, print stack trace, or SOP E also. Okay, three things. So I commented one by one and shown to you. Yeah. So now see, these two methods which you are seeing just now. These two methods what you are seeing now. Which one? Print stack trace and just get message. Class object. Throwable. You are having exception error, all that is fine. You have written this hierarchy, there only you go and write. Just now, earlier you wrote this hierarchy, no? There only you go and write. Get message and print stack trace. These are two methods present in which class? Throwable class, and you can call it in any class. You can call it in arithmetic exception E dot print stack trace, array index out of bound exception E dot print stack trace. You can call it anywhere. It's accessible in what? All the subclasses. All are subclasses of what? Throwable, no? So you can call it E dot print stack trace, E dot whatever you want, you can call it. Clear? Shall I clear this now? Okay. So see, one thing I'll tell you very clearly. Exception handling is a massive subject. Okay. And it will take a lot of time for you to understand what are runtime errors, because for understanding compilation errors only you have taken so much of time. For understanding runtime errors it will take a lot of time. Once you understand what are runtime errors, then you can think about handling it. Handling it is easy. Okay, so slowly you keep on coding, you'll get a lot of errors, runtime errors this time, not which one, compilation errors. And as you go on getting it, you'll go on handling it. More and more examples only will actually make you understand how to handle it. More examples, one example, two examples, you can't understand. More examples are required here, mandatorily. Clear? Okay, so we can catch it. Now I'll show you how to fix the problem also. After catching, what will you do? You can ask the user, please enter proper values. Assume that he gives the value. What will you do? You can divide it and print the message now. Yes or no? So that we can do. So that code where will you write now? The catch block you can write. Okay, so in the catch block you can catch the problem also, plus you can fix the problem also, or fix the error. So let's see. We are starting it in a simple way, then we'll see it in a bigger way. Understood? First learn all these very simple topics. So see here, earlier he had given 0, so you caught it. Sorry, you tried to divide it, exception occurred. You caught it. After catching, what will you do? You can ask him. Please enter proper values. Now he'll give you int p is equal to 10, int q is equal to 2. Here I am still hard coding. Later on we'll do it what? Dynamically. Okay. Int r is equal to 0. R is equal to p by q. Getting it now? So I can print now. Sys out. Value after division is plus r. Simple over. What is there? Supposingly if he gives 10 and 0, now see the flow. It will divide. but error occurs, and that will be caught where? From here it shifts to where? Catch. It will shift here. Now once in catch, what it will do? It will go on executing, and he is giving a new value now. Okay, we'll get it dynamically, don't worry. So once you get the new value, you'll divide it and you'll print it also. And you'll continue it's continuing the executions here. Program has not got terminated. So both the things you achieved. Yes or no? Program is also not getting terminated, and you're fixing the error also. Understood? So this is how you handle the runtime errors. See here, begin main, begin try. See, end try did not execute at all. Begin try gets executed, but these statements are not executed. Control has shifted to what? Catch. Begin catch. Please enter proper values. Fine. Okay. Please enter proper values. Now, int p. Fine. It is dividing, and after division, what is the value? 5. Then end catch. End main. Clear? Now, by chance, if he has entered proper value in the beginning only, 10 and 5 or 10 and 2, some value like this, catch block will not execute. Only if the exception occurs, then catch will execute. Else it will not execute. Understood? Now very simple. See here. See, begin main, begin try. Value of z after division is 5. End try. Are you seeing the output of catch here? Anything from catch block getting executed? No. Finally end main. So program ends normally. If exception doesn't occur, it will not happen. So try block is used for what now? Writing the code which is subject to create problems. Catch block is used for what? Catching the problem raised in the try block and fixing the error. Simple programs you are learning. Are you clear? So this is how you handle runtime errors. In C, C++ and all you check out, it's very difficult. But in Java, very clearly it gave the message when my first program terminated. What did it tell me? It told your program is getting terminated because of what? Arithmetic exception. Since it told it is of type exception, that is why I decided to write what? Try catch like this. And in catch, I know what is the problem. That's why I am catching what? Arithmetic exception. So neatly it is telling you, this is the exception, you handle it and all that. Understood? So more programs you see, you will understand. Clear? Okay. Fine then. Similarly, for this one also we'll see now. Which one? One more we'll see. For array and XOR bound. See here, printing E and all is your wish. Okay, see here, generally when you use Eclipse, it will give exception E. Better you put it as what? Change it to array index sort of one. Because you know now what type of an exception is occurring, you know now. Run the program, you will only come to know. Then you add try catch. I showed you now just now. So you can write it, array index sort of bound. SOP you can print here also. First let's see this output. Begin try, begin catch. First let's normally see this output. So first see, you are not letting the program terminate here. That is the major thing. Then we'll see how to fix the problem. See here, 3 means only try will execute. Yes or no? If the index is what? 3, only try will execute. Will catch execute? No. Why it will not execute? Because the exception has not occurred. So where it will catch? And then it will continue normally. See, begin main, then what? After begin main, begin try, end try, then what? Catch, is it getting executed? No. End main. Program executed successfully. Then if I want, what I'll do? Just I'll change this index to 9. Now what happens? Check out. Exception will occur. But here, what exception is occurring? So this time error is occurring. So J will recognize it. It's of type what? For every problem there is one class I told you. Array index out upon. That object is created now. This time arithmetic will not be created. Array index out upon. So once that object is created, control shift part. This statement is skipped. Once an exception occurs in your try block, the statements will be skipped. Control immediately shifts to catch. Once it shifts to catch, now these statements will be executed. But your program is not getting terminated now. The program is not getting terminated because you are handling the exception in your method itself. If you don't handle, then it will go to the default handler of the JVM. So here developer is having only one duty, just not to let the program terminate. But in other languages, you have to take care of two things. Program also not getting terminated, system also not getting terminated. That's the benefit you have here. It will be caught. Again, if you want SOP E, see this object has got created here. It's or no? Which object? Array index out of bound. It got created implicitly. This E variable will refer to what? That object. SOP E, it will print the message. Similarly, you can call what? E dot print stack trace, E dot get message. All are, you can execute the methods. Why? Because it's a subclass of throwable. You can call those methods. So I'll show you this now. So here exception is occurring now. See the flow. Yes, what has happened? I mean, it will jumble up the output I have told you. Okay, so don't bother too much. So begin main begins execution. Once main begins execution, what happens? Begin try. But end try did not get executed. Why? Exception has occurred here in this line. Immediately control shifted to catch. Begin catch. After catch, what has happened? SOP E. Yes, SOP will print the message like this. ToString has been overridden. Every object in Java encapsulates one information. Now this object is encapsulating what? The error information. Okay, and then after that, okay, anyway, begin catch. Sorry, here I should have changed it to end catch. End catch should have executed, but lastly you can see what? End main. Program has got executed successfully. Your program is not getting terminated now. Understood? If you want, okay, see this. I can just write E. If you want to see more information, E dot print stack trace. Call the method. Now comment this. Run the code. It will give you more information. What information? See, I told you it will jumble up the output. Don't bother. Just see this. This is the exception. It has occurred in this class, method name, file name, line number. All that information it will give you. Are you clear? If you print it, and anyway, see, here it is not important for us, but later on for debugging it will be very important. And if you want, sometimes we use what? Sysort of which one? E dot get message. I can use that also. So these are two important methods which we use extensively later. So the message is what? 9. Only that much it is printing. It's printing a very simple message called as 9. Understood? So just be aware of these methods. When we use it, you'll understand. Okay, end catch. So this is how it is happening. Are you clear? But is my program getting terminated now? Now you have to write the code to what? Fix the error. So how you write it now? We'll see later. Don't bother much now. How to fix the error, don't bother. We'll go with more programs. Just you can decrease the index, or you can increase the size of the array. All that we'll see how to do it. Yeah? Clear this now? So you understood? Yes, now we'll see the document for this. Now exception and exception handling in Java. That's the topic. Exception and what? Exception handling in Java. So Java has provided 5 keywords to do what? Exception handling. Which are the 5 keywords? Try, catch, finally, throw, throws. These are the 5 keywords. Now what is try block? Try. In a method, write the code which is subject to create an exception or error inside a try block. So try is a block. Carefully notice. You have to use the try block where? Inside a methods. You have to use it only within methods. Next, try should be used with catch or finally. That's also mandatory. You cannot use only try. If you use try, it is mandatory to use what? catch. It is mandatory. Only if you write try, you will get the error. Compilation error only you will get. Fine. Why do you use catch block? Catch block is used to catch the exception created in the try block and to fix the error. Catch must be used with what? Try. Catch also must be used with try. It's compulsory. Okay. Now see, try can be used with two things, catch and finally. Right now we are learning try with only catch. We can use it with finally also. We'll see that later. But catch has to be used with what? Only try. That's the combination. We'll see that combination later. Okay. So now just concentrate on try catch now. Don't bother much. Now what happens if you use try catch in your program now? This is what we saw. You saw the output now? This was it. See this. Following things will happen if you use try catch in your program. Step by step I am telling you. First step what? The problem will be identified. Identifies means for those two programs you can write this. Which one? Notes. I showed you the programs now. For that you can write this. Okay. Identifies the Java corresponding class for the problem occurred. Okay. Then what? That exception object is created and thrown inside the try block. Once the exception object is created, all the statements in the try block will be skipped. It is skipped. The statements inside the try block will be skipped. Control is immediately transferred to what? Catch block. The exception object will be caught by the catch block and statements inside the catch block will be executed. Program continues normal execution after catch block. Okay. If no error occurs, then no exception object will be created and catch block also does not get executed. Catch block also does not get executed. Program will execute successfully without termination. Clear? So this is how it happens. Any questions here? Till now? Clear now? Fine. We'll go more deeper now. See, sometimes in a method now, here till now what is happening in your main method, only one problem was occurring. But sometimes what happens when you are writing code now, many problems will occur or many runtime errors. Let's see how you do it now. Okay. So see, this is the combination. When you use try catch now, you have to use try with catch. This concept I covered for you now. Now the next concept which I covered means I gave you an example for this. The next concept which I am covering is one try can have multiple catch statements like this. Multiple. We have covered this example, but now we are going to see this example. Now why will one try have multiple catch statements? Because many type of errors can occur inside one try block. Till now only one error was occurring. Okay, so many errors occur means you have to write many catch block. Let's start off now one by one. Clear? Directly I'll type and show you now. So we'll say multiple try catch now. Understand now why we go for it? Single problem, single catch. Multiple problems, multiple catch. But only one try. Many catches there. Okay, let's see this. I'll club these two now. These two exceptions I'll cover. I mean club into what? Try. Arithmetic also I'll do plus arithmetic out of bound also I'll do. And you notice now, if arithmetic exception is occurring now, it will be caught where? In arithmetic exception. If arithmetic out of bound occurs now, it will be caught in arithmetic out of bound. Neatly it will be caught. How easy means Java has given you excellent support for all this now. Just see this now. New class try catch multiple demo. Understood? So fine. See this. Int x is equal to 10. We'll start off with begin main. Okay, without try catch I'll write first. Int x is equal to 10, int y is equal to 2, int z is equal to 0, then z is equal to x divided by y, done. Then let's run this program normally now. And see what happens. End main, that also I'll put. So here there are no problems and your program executes successfully. There is no problem. So begin main, result of division is 5, end main. Any problems here? No, no. By chance, if you get a value of what? 0. Yes, problem will occur. So we should be ready for problems like this. We should be ready. When you write the code now, you should generally till now you have not written any code in try catch. But when you start writing code from now later on, every time you have to think about what? Exception handling. Okay, it's a major subject and you'll learn it throughout your life, exception handling. Understood? So it's a very vast subject and you get it with experience. So since you got this, what will I do now? The code which is subject to cause problems now. Okay, I put it in try block now. Try. And what is the exception which is occurring now? I found out now. It is, means, see, program is getting terminated. Agreed. You got the message now. Why did the program get terminated? Because of this. And since it is exception, I decided to handle it. I'm not changing my code. I decided to handle it. How will I do handling now? By using try catch. So when I'm using try catch, I'll catch it with what? Arithmetic exception. Fine. And here, SOP, you can print E. Anything you want to print, man, that's your wish. You can print something like that. Okay, fine, this is done. So you're catching the arithmetic exception and you'll also fix the problem. Fine, then I decide to write still more code. Like, okay, 1 second. Begin try. End try. Fine. Now, after this, I decided to write still more code. Now, what is the code? Int A. So, you'll never write only one logic. Many logics will go on writing. So, int A is equal to new int of what now? 5. Then if I give a correct value, what happens? A of 2 is equal to something like 222. You give your value, no problem. So things will execute normally and end try also will execute, no problem. Clear? See, first let's see everything normal. See here, anyway no problem will occur. See this. When the program runs now, 10 is 2, x is 10, y is 2, z is 0. You are dividing. All this is fine. Okay, then you are dividing it also, fine, and everything will happen. Here you have created an array, you are storing the value in the second index, fine, everything is fine. Exception will not occur and catch block also will not execute and main also will execute successfully. But in case arithmetic, okay, first let's see. So begin main, begin try, result of division, end try, everything executes successfully here, no problem at all. Understood? But if an exception occurs, you are ready for only what? Arithmetic exception. You're still not ready for what? Array index order. This occurs, you're handling now. See this. You're catching it. Understood? And it is caught where? In the catch block. In the corresponding catch block, it will be caught. It prints and it prints what? End main. Okay. But if the array index order bound exception occurs, are you ready for it? No. So let's see the flow now. Very interesting flow. Sorry. Okay. See here, arithmetic exceptions are occurring before only. When it occurs there, these statements will never be executed only at any cost. I mean to say, in one try block, you can multiple errors can occur, but at a time, only one will occur. Because line by line execution. So when the exceptions occurred in this line, which line? How will the code reach this line for you? Understood? So for this to understand, what you do, you change the value of y to 2 now. We're following now. Now arithmetic exception will not occur. So it will go on executing. Here it executes, here it executes, here it executes. It will reach here, into which line now? When it reaches to this line, here exception occurs. Which exception? Array index order. Now this statement will be skipped. End try will not execute. Okay, so and once this object is created here, what happens? Once this object is created here, what happens? Okay, here the object is created. Which object? Array index or bound expression. So object is created. So once it is created, now it will check, have you written an exception handler? Yes, you have written it. But arithmetic exception cannot refer to that object. Arithmetic exception cannot handle that. Understood? So E cannot refer to this particular object. You have written it, but it checks. If it's possible, it will try to get handled. Since you have not written it, now again it will come outside. Understood? Same flow, because you have not written the exception handler. Let's see the output now. Are you clear now? For this, what you should do? Remember, see to that arithmetic because you want the statement to execute. See to that, setting the correct value. Program execution should continue here, and here the problem should occur for you. So let's see this. So here array index out of bound exception. So since you did not catch it, it went outside the method, and it was handled by what? Default handler of the JVM, and it's printing the message. But you don't want your program to terminate now. So that's when what you do? Just add one more catch. That's it. Very simple it is. Just write one more catch now. Which catch you will write? You know now which one it is occurring. You will not go and catch anything you want. So you will go and catch array index out of bounds exception. So like this, you go on writing your code one by one, one by one. So now what happens? If arithmetic exception is occurring, it will be caught here. If array index out of bound is occurring, it will be caught here. But definitely your program is not going to terminate. That is fine. But the concept what we are studying is one try can have multiple catch statements. Now see this. Now program will not terminate. Earlier your program was getting terminated. Now it's not getting terminated. See? If you want to print more print statements inside catch of array index out of bound, you'll see now this one will not execute inside arithmetic exception. Are you seeing inside arithmetic exception? Inside catch of arithmetic exception, right? Similarly, you can put inside catch of you only see array index out of bound is getting executed inside catch of what? Array index out of bound. Understood? And SOPE, it's printing that message. That's your wish. Clear? So, but this catch did not get executed. Are you clear? Now, one more thing. Yeah, the concept what we studied is one try can have multiple catch statements. Now, see, one very interesting thing now. So, when one try can have multiple catch statements, why do you want to write so many catch statements? Instead, see this out, I'm commenting that. Why it's giving error, you know? Because the try is there without catch. So I'll write catch now, but just notice. I'll write catch of which one you know? Exception. Why? Because it is a superclass of all exceptions. Yes or no? It is a superclass of all exception. And again, if you want, you can print the message. What? E dot print stack trace. You can print it. Fixing also you can fix. Okay. But the problem here is now, see this. Okay, it is catching. Array index out of bound is also caught. Yes or no? Array index out of bound is occurring. By chance, arithmetic exception occurs. Understood? That also is getting caught. No issue. Program is not getting terminated. Why? Because exception is the superclass of all exceptions. So when it is the superclass of all exceptions, is it better to have multiple catch statements or only one catch statement? Which one is good now? Huh? My question to you is, see, one try can have multiple catch. Why will you have multiple catch? Because multiple problems are occurring now. So you know now, one try, see here, int x is equal to 0, int 10, int y is equal to 0, int z is equal to 0, z is equal to x by y, and at the same time we are having an array. A of 9 is equal to some value you give, that's your wish. In the 9th index I am storing now. Some value you give, yes. So catch arithmetic exception. That's correct what I have written. Okay, arithmetic exception. Then one more is catch. I'll write it in shortcut now. Array index out of bounds exception. See, by chance, if arithmetic exception occurs, where it is called? Arithmetic exception. Okay. By chance, array index out of bound is occurring, it will be called in array index out. Means it will come to the first catch. If this cannot handle it, then it will go to the next catch. It works like this. It's something like if, else if like that. Else it will go outside. If you are catching it, fine. Else it will be going outside. So whenever the first exception occurs, it will come to the first catch. First catch will try to handle it. If not, it will look for the next handler. If not, it will look for the next handler. If nowhere it is caught, then it will go outside. It's fine. Arithmetic it is caught here only, it will execute. If array index out of bound occurs, it will occur. But remember, both cannot happen at the same time. Why? You know, program execution is linear. Okay, either this or this will occur. Check out, if arithmetic is occurring, is there any chance for array index out of bound to occur? No. Okay, if this is successfully executed, then array index out of bound might execute. And it will try to be caught in the first handler. If first handler is not handled, then in the... Are you clear with the flow now? Yes. You understood all this, sir. But my question to you is it advisable to write many catch statements, or I could have solved this problem in a much simpler way? Public static void main, same code you write, only thing is what I'll be doing? Try, write the same code in try. Everything is same. But I'll catch it with exception. Instead of writing 2, I'll write single. Finish now. Let any exception occur. See, if arithmetic exception occurs also, this object, E can refer to that object. Yes or no? Because exception is a superclass of what? All these classes. And superclass variable can refer to what? Subclass object. You very well know this. And by chance, array index out of bound exception occurs. Means, if z is equal to x by y occurs, z is equal to x by y occurs, which object is created? Arithmetic exception. Arithmetic exception. But if a of 2 is equal to, a of 9 is equal to some value 2, now which object is created? Array index. But E can refer to any object. There is no problem with this. Understood? So is it better to write 2 or 1? Result is same.
Because if you want to correct it, you have to use 1.
So those who say 1, you are very lazy. Those who say 2, you are good. Reason is, see, after catching, next you have to fix the problem now. How will you fix now? For arithmetic exception, there is a different logic. For array index out of bound, there is a different logic. Yes or no? So if you are catching it, okay, program will not terminate. Here advantages, program will not terminate. But the problem is fixing now. So you can fix, sir. But see this, sir. You have to write the logic like this. If, your story will start now. If E instance of arithmetic exception, then write that logic. Else if, next one. E instance of, so in catch block, you have to write big story now. What? Means if A is E instance of arithmetic exception, you ask the user to give the value. Int P is equal to 10, int Q is equal to 2, int R is equal to, write the logic. Similarly, write logic for what? Array index one. So it becomes headache for you. So in the catch block, you are forced to find out, you caught it. Program has not got terminated, but you are forced to identify it's of type what, and then write the logic. So if arithmetic exceptions are occurring, this condition will execute. If array index out of bound is occurring, this condition will execute. But you are having the headache of identifying now. That's what they say. Don't do all this. Better you go with what? Writing multiple catch. It will only detect and it will only catch now. If arithmetic exceptions are occurring, where it will be caught? Arithmetic only. If array index out of bound is occurring, where it will be caught? Array index. So correct logic gets executed. We don't have to worry too much about this. Wherever the exception occurs, whichever error occurs, the correct catch block gets executed. So better go with this. So write multiple catch statements instead of using exception. Understood? So this is the best way. In companies you have to follow this standard itself. Okay, even though one exception he can handle all the exceptions, it's better you write multiple catch statements like this. Are you clear with this? Fine. Okay, now when you're writing multiple catch statements, now comes the order. You're writing you understood now why you write, how to write, all that you understood. So which one is better finally? Here, because writing logic is very simple for you here. See here, instead of all that, see here. Int p is equal to 10, int q is equal to 2, int r is equal to p by q. We'll write it. Similarly, you write the logic for what? Array index order. So for one exception, you have got one logic. So it will be correctly executed. If arithmetic exception occurs, that logic will execute. Array index order occurs, that logic will execute. You don't have to worry anything here. But there you have the extra headache. So in Java is giving you so much of flexibility. Take the advantage of it. Clear now? Yes sir. Now once you understood writing multiple catch statements, now comes the order. Which one should be first, which one should be second? Okay, now notice. By chance, in this example we'll take now. Everything is perfect. By chance if I write catch exception E on the top, what happens? Whichever exception occurs, it will be caught here only now. Why? Because it's the superclass of all classes. It's the superclass of all exceptions. Exception is the superclass of all exceptions. It can be caught here. Arithmetic also will be caught here only. Array index order bound also will be caught here. So when you are writing multiple catch statements, the order is very important. Remember, always superclasses should be in the bottom and subclasses should be on the top. Understood? No, superclass should be in the bottom, but subclass should be on the top. Means here, don't write a catch exception here. If you want to write still, by chance if you want to still write it where? Bottom. Now what about these two order? This can be in any order. You can write first what? Arithmetic, or you can write array index order. Here order is not important because they are not related only. Is arithmetic exception related with array index order bound? Check the hierarchy. I gave the hierarchy tree now. I gave the hierarchy tree. This is the reason I gave the hierarchy tree, because these two are not related. It's something like, see, A class is there. B and C are subclass of what? A class. But B and C are not related, no? Same way, both are subclass of what? Exception. But arithmetic exception and array index order bound are not related. So this is how they will be related. So if you want to use, always you have to use what? Subclasses on the top and superclass in the bottom. If they are unrelated, you can write it in any order. Means, see here, instead of catching arithmetic exception first, if I write catch array index order bound exception, what will happen? Nothing will happen. And similarly, see, I am catching it ulta now. First I am catching what? Array index order bound, then I am catching what? Arithmetic. See now how the execution happens. Z is equal to x by y. Which object is created? Arithmetic. Where it will come? To the first catch. Can array index order bound handle it? No, it cannot handle it. So it will go to the next catch. Arithmetic can handle it. Understood? When they are not related, you can write it in any order. And it doesn't mean that you have to write the exceptions in the same order in which they are occurring. Like if arithmetic is occurring first, don't think arithmetic only should be written first. Array index order bound is written first, don't think array index order bound only should be written first. You can write it in any order. Okay, so your order of catch block will not depend on the order of error here. Order of catch block will always depend on actually what? Superclass and subclass relation. Order of catch block will always depend on superclass and subclass relation. Always subclasses should be on the top and superclass should be in the bottom. Okay, and if you write it also by chance, okay, by chance if I write catch exception E, what happens? It is treated as compilation error. It is treated as compilation error. Good only, no? Why good? Because by chance if you write catch exception E here, I'll write it off. What I'll write? Catch exception E I'll write. So after writing, now I'll run the program. Where it will be caught? Here only it will be caught now. And you'll start wondering during runtime, why is this not getting executed? Why is this not getting executed? So much of benefit. They're telling, okay, this is treated as syntax error now. If you use superclass on the top, it will be treated as a syntax error itself. Understood? That's benefit what you're getting. Okay, because unreachable code in Java is what? Error. And if you put exception E on top, what happens? This code can never be executed only. So that will give you definitely unreachable code error. Compilation error only you'll get it. Are you clear with all this now? So one try can have multiple catch statements. Shall I clear all this now? Okay, we'll see it with what? Output only, very simple. So yes, we learned now, even though one try can have multiple catch, okay, it's good to go with multiple catch only instead of what? Single catch like this, fine. Now, by chance, if I enable now, see I had commented earlier, I'll write now. It's give me error. Why? Because you have used superclass in the top. But if I put it in the last, the error will go. That clearly shows that superclass should be in the bottom and subclass on the top. Clear with this? Okay. Now, I'll comment this. Now, what about the order of these two? Which one should come first? Arithmetic or array index out of bound? That can come in any order. So, I'll cut this and I'll paste it below here. But in the code, you can see first which exception is occurring. Arithmetic. Okay. And if arithmetic occurs, it will come to the first catch. If it is not handled here, it will go to the next catch. This here order is not important because they are unrelated. So when they are related, subclass on top, superclass in bottom. When they are unrelated, you can write it in any order. Clear? Fine. So now if you want, you can run this program and check out now which exception is occurring now. Okay, I'll see to that arithmetic only occurs. Which one will get executed? Arithmetic only will execute. Check out. Understood? Array index out of bound did not get executed. And you understood the compilation error now if I put exception on the top? This you understood now? Why? Unreachable code error. See, it's telling unreachable catch block. So during runtime, you'll start wondering, why is this catch not getting executed if it had compiled? Understood? So that's why what they did, they know they are very intelligent programmers like you. Okay, so that's the reason they made it as syntax error itself. Correct? After coding, you'll start searching the why error is occurring and all that. So like this, most they can detect and bring it to compilation time. Compiler is very powerful in Java. Clear? Yes. So the document for this you can see now. Yeah. See, one try block can have multiple catch statements. Yes. See, all our points. For every point, what I have to give you? Example. That's it. Nothing else. We are seeing a lot of concepts. Every point is one concept. For every concept, you need an example. More examples you see, more better it becomes. That's it. Fine. See, one try block can have multiple catch statements. In some cases, more than one exception can occur in try block. To handle such situations, one try block can have multiple catch statements, but always one type of an exception object will be created in try block. And only one catch block gets executed. Remember that also. How many catch will be executed? Only one. So when an exception is thrown, each catch statement see, when an exception is thrown, each catch statement is inspected in order, and the first one which matches the exception will get executed. First one which matches it. Okay, next. Even though a class exception can handle what? All the exceptions, it is always advisable to write the specific type of exception in the catch block. Because after catching the exception, next we have to check the type of exception which has occurred and then write the logic to fix the error for that exception. Why we go for multiple catch statements is this reason. Next, when we are writing many catch blocks, always subclass should be on the top and superclass should be in the bottom. Okay, we cannot write any statements between try and catch, and also you cannot write any statements between catch and catch. So this completes try and catch. Yeah, but one more famous interview question would be, are you clear with all these points? Examples I gave you? Yes. So one more very important interview question what they ask is, see this one. Write the try catch order for three classes they'll give. Example, they'll give exception, file not found exception, file not found exception, and IO exception. So they'll give 3 classes like this and ask you to write the order. Write the try-catch order for these 3 classes. If it is arithmetic or index order mode, you can write it in any order. But for this, you should be careful. So first, try, catch. First, which catch? From the, I wrote it, I've jumbled the order. But actual cases, you can see the tree, hierarchy tree. Lowest is what? File not found exception. Write it fully. You have to write file not found exception. Then next catch will be what? IO exception. File not found exception E, IO exception E. Then what? Catch exception E. For interview purpose, you should know this. So this is subclass. This is superclass of this one. This is superclass of both of them. Understood now? Very, very important equation. Always subclasses should be on. Here I use 3 subclasses, so it becomes more clear. There are only 2. Arithmetic exception was subclass of what? Exception. But here, more story is there. File not found is subclass of IO. IO is subclass of exception. So when they are related any order, when they are related, superclass bottom, subclass top. When they are unrelated, any order. Clear? Okay. Should I clear this? Okay. Now, all the exception handling, where did we do? All the exception handling, we did it in the main method. But who will write logic in main method, man? Nobody will write now, you know that very well now. So actually we have to study how to do exception handling in other methods, not in main methods now. Beginning we start off because you are addicted to learning in main. But later on we have to move to exception handling in other methods. Understood now? So we'll see how to do exception handling in other methods where we write. Because nobody will write the logic in main now. Main will only do what? Go on calling methods. More than that you will not do. Because all the logic you write in main, how will you reuse? You know the object oriented concept. All the code we write it where? In methods. Methods will be kept where? Classes. Classes will be kept in packages. That's how you go on organizing. So nobody will write the code in main now. Let's see now how you do it. See this very interesting flow. You are so much worried about fixing the problem, but gradually you will understand fixing the error becomes very, very easy. As you complete the subject of what? Exception handling, then it will become very clear to you. Okay, so just see an example. There is a class called as hello and there is a method called as void m1. It will have 2 parameters. So m1 is a method which goes on to do division of what? 2 numbers. Carefully see this. Int z is equal to 0, z is equal to x by y, SOP, value of division is result of division. Anything you print, man? Result of division is plus x. Excellent, you have written the code. You have written the code here. Where? If you want to divide 2 numbers, that logic you have written it on method, that method you have kept it in on class. Perfect. There's no problem with this. And now, once you finish writing the class, next what will you do? You will use it. More than that you will not do anything. Because division logic you start writing where? In class, main, you can't reuse it. So that's why we do like this. So now see this. Carefully observe. So we will get the values. How will we get the values? Int a is equal to 10, int b is equal to 2. You will get these values dynamically, don't worry. We will get it. Once you get this, now I want to divide. So what will I do? Hello h is equal to new hello. Yes? Now see, I'll call h dot m1 and I'll send the values a and b. SOP you write begin main, end main. Okay, or I'll write here SOP end main. Carefully observe what happens. If values are correct, everything will execute perfectly. There is no problem here. But by chance, if the user has given a value called as 0, now problems will start off. So how it will start? This line will execute, this line will execute, this line also object will get created. You're calling the method also gets executed. But during the method execution, problem occurs. Where it is occurring? This line. Which object is created? Arithmetic exception. Perfect. Arithmetic exception object is getting created. So once it is created, the statements inside this method are not executed. It will terminate. It will check, are you writing exception? Same, how it was working in main, no? Same way it will work here. It checks, are you writing an exception handler inside this method? Are you writing it? No. Since you are not writing the exception handler inside this method, this statement is skipped. Agreed. Which statement? Definitely it will skipped. It will come to caller. Who is the caller of that method? M1. So again, it checks, are you handling the exception here? Here also you are not handling. So this statement will be skipped. Again it will go where? JVM. This is the flow actually. From that method it comes to this method. From this method it will go outside. It's the perfect flow. So same was happening in main method. If a problem was occurring here, what was happening? It was going outside. But it will become more clearer here. Because why? From M1 it is coming to main. From main it is going outside. Till now you have seen only going from main outside. Are you clear with this flow? So fine. Now you have to handle the exception because your program is getting terminated. So one option for you to handle this exception would be what? Write try catch. Yes. Where will you write try catch? See the problems now clearly. See how Java is giving excellent support for programming. See this now. I'll start using try catch. I'll write try where catch. What will I catch? The brilliance of Java now you'll start seeing. That is normal. Till now what you saw was normal. Okay, now see the brilliance of Java. So catch arithmetic exception E I have told. Fine. After catching it, see now, if values are correct, we have written try catch this time. Why did I write try catch? To fix the problem, correct? To catch the error also and to fix the two things to be done now. One is to catch the error. Second one is to fix the error. So now see, I'll pass 10 and 2. Let us see it without error now. Okay, so you are sending the correct value, exception doesn't occur, this statement execute, catch block also will not execute. Okay, catch block will not execute. SOP end of M1 you write. SOP end of M1 you write if you want SOP begin of M1. Okay, so nothing means catch block will not get executed this time. Yes or no? You agree with this point? Yes, because we are not sending a wrong value. But by chance if I send 0, now a lot of things will happen. What will happen? It will come, the values of A and B are given to X and Y, and after giving to X and Y you are dividing it. Yes, exception occurs. Now, after except we caught it. But next you have to write the code for what? Fixing the error, no? You have to write the code for what? Fixing the error. So you will write, how will you write? Int P is equal to, you'll ask the user to give the values. Yes or no? He'll give it now. How will you give? Int P is equal to 10. See here, SOP, you can print a message. Please give correct values. So you are writing the code now. Please give correct values. So he'll give int P is equal to 10, int Q is equal to 2, int R is equal to P by Q, and you can write SOP, result of division is plus R. Yes or no? SOP end of M1 now. Again, means if the exception occurs now, see there, M1, you are sending a wrong value. Exception object is created. Which one? Arithmetic exception. So since that object got created, you are handling it where now? Inside the same method. You are handling it inside the same method by writing an exception handler. You wrote it now. Catch X, arithmetic X, you caught it. After catching it, you are fixing the problem also. So what are you doing now? You are doing two things. One, retain control in the program. Plus you are fixing the error. Two things you are doing. Everything is correct. You are happy with this now? You are happy with this? Yes. But the problem is, just observe in the catch block you are rewriting the same logic again and again. Which one? The division logic. You are rewriting the same division. This line has been redundantly written again and again. It's not one line, sometimes there will be many lines. Here we are writing a simple line. You are rewriting the same code again and again. Why do you want to rewrite it again? It's better you reuse it now. So that is why always when an exception occurs now, it is better not to handle it in the same method, but instead handle it in the caller method. Because actually fixing the error is nothing but what? Re-executing the same logic with proper values. Fixing the error is finally nothing but re-executing the same logic with proper values. It's so clearly told. Understood? So now, why are you writing the logic again but? So that is why what I'll tell is, do not write all this here. Remove it. So when an exception occurs, what happens? Leave it as it is. Earlier what you had written, no? Same way you maintain. So when an exception occurs, what happens? It will come to the caller. Which object is created? Arithmetic exception object is created. Are you handling it here? You are not written any exception handler. Are you writing try catch here? Don't write try also, don't write catch also. Obviously when you don't handle it, it will come to the caller. So once it comes, what you do here? Here you catch. Because if you don't catch here, what will happen? It will go outside. Program will terminate. So it's always, generally what we do, we catch it in main only. Okay, in main or in the last, in the main caller. We always handle the exception in the main caller. Okay, so here what will I do? I'll write this time try catch. Yes, we are catching it. I'll write in try catch now. So here you write, okay, try catch. What will you do? Arithmetic exception. So after catching it, what will you do? 1 second. Yeah, h dot m1. Here the line problem is occurring now. Ask the user to give proper values. He'll give int p is equal to 10, int q is equal to 2. h dot m1. Call the method with proper values. Finish now. Why do you want to write the same logic again? So always do not handle problems where, or do not try to catch the problem and fix the problem in the same method. That's what I'm trying to say. Do not try to catch the problem and fix the problem in the same method. Okay. Catching problem and fixing the problem should be done from caller method. But since we learnt everything in main, there it is mandatory you have to catch and fix it in the same method. Why? Because that's the main caller, and what will happen if you don't handle it here, it will go to the JVM. Understood? But you see from other method point of view, always what will happen? You will call that method. Okay, and if any problem occurs, it will come to you only, and what you do, you will call that method with proper. Isn't this brilliant? Which language gives you the support? That is why when an exception object is created, okay, it's your wish. Either if you want, there are two options for you. You can handle it in the same method or give it to the caller. We maximum prefer to give it to the caller itself. And once it is given to the caller, caller will catch that problem and or fix that, catch that exception. And how does it fix it? By reinvoking the method with proper values. That's it. By reinvoking the method with proper values. This is the best way of doing exception handling. Reinvoking the same method with proper values. Instead of writing the same logic again and again. Are you clear? More examples will make you clearer. Doubts will come, but the answer to all your doubts is only examples. More doubts, more examples. That's it. Understood? So this is the first time you are understanding what is a what? Runtime error. In your lifetime you never knew what is a runtime error properly. Understood? You only, for understanding compilation errors only you have taken so much of time. Now imagine how long you will take to understand what? Runtime errors. So it will take some time, and as you go on getting runtime errors, these problems will be solved for you. Clear? It takes little time, that's it. More examples and time. Should I clear all this now? We'll code and see this program. So from here it starts off. Java takes off. Where? It is better than other languages. Java's exception handling is the best as compared to what? Any programming languages. The support you are seeing now, and also you will see the support of what? Still 3 more powerful keywords are there. Which one? Try, catch, find it. Till now what you saw was normal. In many languages will give some small support for all that. But from now what you will see will be the extra features of Java. Let's say this now. Name. 1 second, I'll name this as 3. This will become 4 now. Now you see in this class, means I'll write one class code as hello in the same file itself. No issue. I'll write it in the same file. Z is equal to 0. Everything perfect here. Now see what happens. We'll start it with we'll start this coding with simple. Start itself. Always code like this. Don't rush. Start begin basics. Sys out. Begin main. End main. So once this is done, see this. This main will try to use what? That code now. How will it use? Hello? H is equal to null. Okay, you can declare a variable. Okay, then I'll declare some more variables. Int A is equal to 10. Int B is equal to 0. H dot M1. And I'll pass A and B. See, normally when till now you have written code like this only, means you're all sending correct values. That's why errors were not occurring for you. H dot M1 of what I'm sending? Sorry, 2 I'll send first time. Yeah, I have to create the object, no? Sorry. H is equal to new. Hello. Done? Let's see the code now. Everything will execute successfully now. In fact, begin M1, begin end of M1 also will print. See this. And now see this, how it executes. Begin main, begin M1, end main. Any problems here? Perfect. Normal execution. But by the same time, if I send a wrong value now, yes or no? I'm not dividing only, sorry. Z is equal to X by Y. Okay, we'll see it with correct value then. 10 and 2. Okay, I'll execute with correct values. So begin main, begin M1, result of division is what? 5, yes or no? Result of division is 5, end M1 method and end main. Any questions here? No? Okay, now you see what happens. See here, this is very important flow now. Very crucial flow. Now main starts off execution. Begin main, yes, main begins execution. It will call M1 method. M1 also begins execution. You are trying to divide. What happened? Exception occurred. Now see the trace. It has occurred. In fact, it's giving the name of the thread also. You forget threads now. Okay, the name of the thread is main. But look at this. This is the name of the exception which has occurred. Okay, and it is divided by 0. How did it occur? See, it's giving you the trace. Main method in try catch 4 class. This fully qualified class, com.cluster is fully qualified class name. In this class, main method has called which method? M1 of hello class. Understood? It has called. So actually problem has occurred in line number 9. From number line it came to what? Line number 23. It's giving you full trace. Okay. So and it is caught, I mean since you are not catching it, it is caught by whom? The default, and see from there the exception object here where it is. Here the object gets created, straight away it will come to what? This method. Now this also is not getting executed, end main didn't get executed. Notice what is the output you are seeing? End main is not there, end M1 also is not there, end main is also not there. And outside main, since you are not, it checks. When the exception occurred in this M1 method, it checks are you handling it here. If you are not handling it, it will go to the caller. There also if you are not handling it, will go to the next call and it will be handled by the default handler of the JVM. But system does not get terminated. So that you don't bother only in Java. System getting terminated, don't bother. It's not like in C language, any problem occurs, you restart your computer and all that. Okay, here it will be caught by the default handler of the JVM. But I do not want my program to terminate now. Yes or no? And I want to fix the error because user can give this value. So one option would be writing where? Try catch inside this method. Yes or no? One option would be what? Writing try catch here, which is not logically correct now. You might get the output. You might get the output. Try what you do. So I'll not show you. Just understand. You can write try catch here. Okay, let me see. First time. You can write it like this. Try your return. Then what will you write? Catch. Which exception? You know now. Arithmetic, it clearly told you it occurred at this line number. Which line number? 9. So I'll put all that code into what now? Try block. So and of type, I'll catch it of type exception E. Once I catch it, then what will I write? I write the code for debugging. Yes or no? Means I'll ask the user sysout, please enter and user will give now by chance int p is equal to 10, int q is equal to 2, int r is equal to 0. You can write. After writing, what will you do? R is equal to p by q. You can write like this, and then you can print result after division is. They'll come values dynamically. Values will come dynamically. Don't worry about that. Okay. So it will be executed. R correct. So then end of M1 method, fine, it will end, method will complete now. Method will execute successfully, and then after, if that executes successfully, main also will execute because problem occurred there only you caught, there only you fixed, fine. There is no problem for main now because the problem is not coming to main. So fine, this is a good solution. See, begin main, begin M1. M1 begins. Okay, M1 begins execution. This is M1 method. You are trying to divide. So now see this. Result of division. This is not printed. So what happens? It will come to catch block. Please enter proper values. And then what? Result of division is end M1. All this will print. But from here, catch block. All the statements are executed from catch block. After catch, it will come to what? Main. End main. Main also gets executed. See, end main. But the only thing, the drawback in your code is you are rewriting this logic again and again. It should not happen. So that's why we don't write what? Try catch here. Are you clear with this? Are you clear? I'll remove it. You understanding now? So what we do? We should not write try catch in methods like this. Always try catch will be written where now? In caller methods. Try catch will be written not in the same place where exceptions are occurring. Try catch will be written always in caller methods. Okay. I'll delete it off. Okay. Yeah, this was our code now. So what will I do now? Hello h is equal to null. So here the problem is occurring now. So put this in what? Try. So now you write catch which exception? Arithmetic. Now in try block, you try to call the method. Once you try to call the method here, if in case exception occurs, then again you can tell what? Please enter proper values and write int p is equal to 10, int q is equal to int q is equal to 2, then simply I'll call h dot m1 of p and q. That's it. And now this catch block will execute. Program will not terminate. Still it is executed successfully. Are you clear with this? You want, you can see the flow now. You type and track this all this man, end of, say result of division. See, first time begin M1 begins here the exception occurs. Once the exception occurs, it will come to what? You put on SOP here also. It will come there. So once it comes, now what will happen? You are sending correct values. So again M1 is getting executed, yes or no? Again, because you're re-invoking the method with proper values, it will execute and it will print result of division is 5. Then after that, end of M1 also is executed. Why? Because no exception occurred. And then control will come to main and completes the main also. So this is the best way of fixing the error. Instead of fixing it in the same method, fix it in the caller. Are you clear? Any questions here? Any questions here? So this is the introduction of what? Exception handling. Okay. Are you clear with this? Any questions you are having? Go check this out. You'll understand. So from tomorrow we'll start writing, doing exception handling where? In other methods only. Very rarely we try it in what? Main. Okay. That we'll see tomorrow. Yeah. Any questions now? And some more things what you have to do is, these are some more combinations what we can write for try catch. I showed you try with single catch. I showed you try with multiple catch. Then you can also do like this. Try, inside try what you can do. This is called as nested try catch. Again this will have its catch. This is also valid. But I have not given you examples. Don't worry. In your life when you go on coding you will come across these examples. There you will understand. Okay, because I go on giving more examples you will become burdened. Understood? So learn, get the basics. When we start developing applications, all the scenarios will come and there you will understand this. But these are valid syntaxes. This is valid, this is valid, this is valid. And check this out. In try, we're having catch. In catch also I can write what? These are all valid syntaxes. All the four are valid syntaxes. And these two are called as nested try catch. Means writing try catch inside try or writing try catch inside catch is called as what? Nested. Writing it inside it. Yeah? We'll see examples for that later. More examples I'll give. Yeah? Clear with try catch now? Any questions you're having with try catch? Ask. It will become more clearer. I'm telling you it will become more and more clearer as we progress. Okay. This is the first time you are seeing runtime errors. Okay. And in fact we have written code in such a way that no errors were only occurring. That foolproof you were. Yes or no? You are writing code because we are not getting dynamical values, we are only coding. But later on when we start getting values dynamically, these problems will occur. That's why I have still not shown you how to work with dynamic values. Once I complete all this, then I'll show you how to get dynamic values. Some more topics are pending now. So we are still continuing to learn what? Can you guess? I'm teaching you what? How to write methods only. Still continuing with the same topic because always logics are written in methods. And for logic to execute, we send arguments, values. And if it doesn't work properly, Java has got an excellent mechanism. It will give the problem back to what? Caller. And caller will re-invoke the method with proper values. What an excellent mechanism, man. Excellent. No words to explain this. Okay. In fact, in one day you got the grip of exception handling in Java. In other languages, to get the grip of it only, it will take what? 15 days to 1 month. Try with C, you will come to know. That is one of the easiest language you know, no? Try. Understood? So Java is giving excellent support for exception handling. So it will be easy provided you work and code more programs. That's it. Okay, that's it then.